Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Exponential Function Basics. Concept number 2, the domain of an exponential function. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a new paradigm. I want to include everyone who needs a boost in Algebra 2. And if I could stick every math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose of Algebra 2 by purchasing the complete cram session beyond the exponential and logarithmic function basics, okay? And you have lots of friends, classmates, and colleagues who could really benefit from this cram session as well. Be sure to spread the word and tell them to inbox me at memedicine@gmail.com so that they too can purchase the complete cram session. You'll be glad you told them to purchase because they'll make great study buddies. And last but not least, the concept of cramming often has a negative connotation. But what people are actually thinking of is hurrying, which is a result of fear and can consequently be destructive to your learning process. We're not hurrying here, we're cramming, and there's a huge difference. Hurrying is jam-packing tons and tons of unorganized information into your mental DNA over tiny amounts of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way in what seems to have been an instant. Let's delve into the concept of the domain of an exponential function. Exponential function. What is the domain of the exponential function y equals b to the x? Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you were able to press pause and come up with a solution. If not, that's completely fine. Let's delve into this together. In the general format for the exponential function, y equals b to the x power, we have our constant b, our exponent x, and our power y. Sometimes the exponent is called the power, but that's actually a misnomer. Let's say this x had a value of 2. The result or output y would be the second power of b, of the constant b, okay? All right, and what differentiates this format from a polynomial function is that you have a constant raised to a power rather than a power, which is a variable, rather than a variable raised to some numerical constant, okay? So don't get the two confused. All right, so this is what the graph of y equals b to the x would look like. And here we have a classic exponential growth function. That's because our constant b, in this case, is greater than 1. Thus, the output or the y values are increasing as the value of x increase, okay? And notice down here that we have a vertical asymptote of y is equivalent to 0, where the graph moves away from 0 and never touches it, okay? So note that in this format, we're only concerned with the positive form of b, so basically we don't want b to be negative, okay? So for this particular instance, y equals b to the x power, our constant b will always be positive. So no negative b's allowed. And I don't mean, well, what, you know what, forget it. So -2, let's say we were to plug that in as our constant. That would be problematic because if our exponent were 0.5 or 1/2, what we would get is the square root of 2, because we know that when the square root of -2 rather, we know that when we evaluate a fractional exponent, we raise the base to the numerator and we take the nth root of the denominator. Okay, so we take the square root or the second root of -2, and two interesting things happen here. First of all, you get the square root of -1. This is the imaginary number I. And the square root of 2 is an irrational number, meaning that when you try to evaluate it, it's going to be a repeating decimal that never terminates. So if you were to try to evaluate the square root of 2, you would get something like 1.41, blah, blah, blah. Okay? So this becomes 2I, an irrational imaginary number. No, 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 we're not dealing with this. This is why b cannot be negative, at least for now, okay? And also, we don't want b to be 1. Why? Because if our base is 1, if our constant is 1, you could plug in x from -infinity all the way up until infinity, and you're only going to get 1. So basically, you would just flatline, okay? You would have an output that's like only 1, and we don't want that either. That's a little weird. Okay, so yeah, those are the restrictions for this particular problem. So keeping that in mind, we're now going to try to find our domain, okay? And again, in the event that b is not negative, and but b is made into a fractional value that occurs between 0 and 1, then this is what the graph would look like. It would be a classic exponential decay function where the y values or the outputs are always decreasing, always approaching but never touching the horizontal asymptote y equals 0. Okay, so I just want you to know that whether b is greater than 1 or between 0 and 1, the domain is going to be the same for both cases. And just in case you don't even know what the heck domain means, basically the domain of a function is a set of all x values that makes our function true, okay? So again, the domain is a set of all x values that make the function true, where there's no holes in the graph and it's continuous, okay? So for y equals b to the x, where b is not negative, b is not equal to 1, and b is greater than 0 or between 0 and 1, the domain is going to be all real numbers, okay? So that's our answer, all real numbers. And a real number is a value that represents a quantity along the number line, or sometimes referred to, most of the times referred to as the x-axis. And real numbers include all rational numbers. Rational numbers can be written in fractional form. So this is a notation. The domain is a set of all real numbers. This is how you represent real numbers, okay? But let's get back into the particulars of all real numbers. It can be represented as a fraction a over b, where a and b are integers, and some examples of integers are basically counting numbers that you will find along the number line or x-axis. They could be numbers like -2, 0, and 1, but a caveat is that b is not equal to 0, because then the fraction rather, would be undefined, and b can be 1, okay? That's okay. Because actually, all these integers have an invisible 1 beneath them. It's implicit, all right? And the nice thing is that when written as a decimal, if the fraction is evaluated, rational numbers terminate, or rational fractions terminate, or they repeat, such as 2/3. You would get like 666, 0.666 rather. So repeating is okay, terminating is okay. That makes the number rational. Sorry for the lag time. I've been promising you guys new writing tools for like forever. Coming soon. All right, so this is a rational number because you would basically get a repeating decimal of 6666666, okay? All right. And some examples of rational numbers are integers, such as -5, which we mention here, and the fraction 4/3, which just zoomed by really quickly. Sorry about that. Let me show you. So 4/3 is an example of a rational number as well. Okay? And real numbers also include irrational numbers. Irrational numbers, as indicated here, they can't be expressed in the fractional form a/b because when written in this way, rational numbers are decimals that don't terminate or repeat. An example of a rational number would be the square root of 2/1, because when you evaluate the square root of 2 in the numerator, it's something like 1.41421356 ... Okay, so yeah, this is like no bueno. We don't want that. So again, real numbers include both irrational numbers. So the domain, in short, is all real numbers. The numbers along the number line or x-axis, okay? All of them. Intellectual comprehension of this particular subject matter was not difficult at all. And after the short amount of time it takes you to complete this entire cram session, you'll be prepared to answer a battery of questions about any Algebra 2 concept. So inbox me at memedicine@gmail.com to purchase this complete cram session. Good luck studying, and thanks for tuning in.